Yes.
But if you poured it in a glass, you probably wouldn't really notice the difference.
You would not notice the difference, and that is crucial, because a white toilet, you bring water into it, you want it, that it has to be clear water.
Tapping in tomorrow, surging and emerging smart water plays. We're going to talk about two things, and I've got two folks with me that are super special. Jonathan and I have been together multiple times. He has absolutely critical piece of information that you have to understand. He is going to educate you about water quality and what it does to copper, PEX, and his product, Flowguard Gold. This is a really serious issue. It's a problem all over the country. You're going to have to pay attention because you can end up in a really, really, really bad situation. Now, the good news is it's really simple to go test the water and know what you need to do. So it doesn't necessarily increase your costs, but it's something, if you're a builder, you need to understand this science. You need to pay attention to it. And then I met Melissa today, and about 4 years ago or whatever, 5 years ago, I went to CES, and I was at this little press event before the thing opens for like the award-winning products. And I quickly cruise through it to see if there's anything for housing, stuff there. And I run across this company called Hydraloop, and I couldn't believe it. It was like, what the heck? There's actually a housing product here. And we've seen the full circuit. That was your international debut. And this year you were at the International Builder Show. I saw you there as well. And now they're at Builder Innovator, and they have a really interesting product to make us rethink water use in the home and gray water and all those systems. So both of these, I think, are going to be really interesting talks for us today. So we just the three of us up here, Jonathan and Melissa. So we're going to have plenty of time. We're going to have time for audience participation, luckily, in this session. Before we get started, play our little message from Hyarc, who's sponsoring our entire track. And this is a final little message from them, but they've been kind of fun videos, so take it away.
Home builders have really complex products. They don't just build one home, they build a configurable lineup of homes.
There are so many assets that are needed across the business that spans from construction documents, to purchasing and estimating data, to marketing collateral. All this information needs to be kept in sync.
Change across your business functions as a kind of wrecking ball. Every time you kind of hand off that set of documents, it's almost like a game of telephone. The information or the data that's supposed to be there sort of changes.
Updating each of these assets is done by different people in different departments and different tools. That process is slow, it's arduous, and it's antiquated.
Hyarc was started to totally change that. What Hyarc does is it strings together those departments.
Hyarc developed technology to integrate all of those assets and produce them from one centralized data model.
So if you want to change the head height, for example, of your windows across 3 lineups of plans, you can do it all at once.
Hyarc enables builders to automate any kind of document they would like to produce. Construction documents, master plans, brochures. It could be any kind of documentation that allows a builder's business to run more effectively.
Hyarc can take 100 hours of work and turn it into a few minutes.
We're going to reduce the time it takes to build. We're going to reduce the number of errors on a job site, and we're going to improve the customer experience. Anytime the buyers are wanting to see their house as it's going to be built, Hyarc represents it for them in 3D.
At Hyarc, we're incredibly excited to lead the development of this new class of technology that will enable home builders to create better homes and better communities. This is just the beginning.
Our goal is to be your partner for the next 30 years. We're building our business to last, and we're excited about the future.
Now we're going to talk about water. And, nothing's more essential in a home, but from a builder perspective, to me, nothing's more worrisome in a home. Water leaks are bad news, all the way around, whether than the foundation, whether it's because of foundation shifting, soil conditions, whether it's because of construction defects, running screws, nails, fasteners, different things into water pipes at different times. But we're going to learn today, about some other issues of why we're going to have challenges with water. But it's also a precious resource, and builders are finding it harder and harder to get homes permitted in some cases. Communities are getting way more aggressive with rebating to figure out how homes can use less and less water. And I always thought about it being Tucson and Phoenix and Las Vegas and some of these desert locations. I know as a Texas resident, we now have issues in Texas where we're having water issues, and sometimes we're even having permits being slowed down and permitting being stopped or halted in some cases until new water sources or rights are actually secured. You informed me today that Florida even is having freshwater problems because tapping into the aquifer, and cities are offering rebates to different appliances that reduce the amount of water. So, I think it's a shock to me. You said, Florida, my God, they're floating in water. There's water everywhere. You'd think that would be the last place on earth we'd have this problem. But it was really enlightening to talk to you this morning about that. But Melissa's going to kick us off. She's going to talk about brand new technology that can help us use at least about 25% less water in a home.
All right, so as I said when I spoke to a lot of you, what I'm focused on is decentralized. What I may not have mentioned is, there are a lot of states throughout the US that do have centralized water reuse systems, and this is wonderful.
That's the purple line at the golf course, for example.
Yeah, that's the purple pipe that we all see. And if you drive around anywhere in Florida and you see any irrigation, there's usually a sign that says, "This is
don't drink this water."
Yeah, don't drink this water. This is the purple pipe system. But the centralized water reuse only captures between 50 to 80% of the gray water we have. And gray water is so easy to treat. So with decentralized, it's in the home. We're not adding to our carbon footprint because 5% of the world's energy is used to move water. If we keep it and treat it where we have it and use it for other...
So it's kind of the same analogy. The previous session we had was on energy, right? And we're kind of talking about 7% of all the energy lost in the country is lost from transmission. 40% of energy that we have in the United States is lost because we have to keep power plants running regardless of what the load is. So we actually throw away 40% of our generation because there just isn't demand and you can't turn the plant on and off, instantly or anything like that.
Exactly.
So it sounds in a way like water has a similar issue where this decentralized, getting it back to treating it at the property rather than send it all to some huge municipal huge capital investment, right? Someplace else is really a more effective and efficient way of dealing with it.
It is, yes and no. I think the two combined together operate the most effectively because by recycling it where we use it, it brings our carbon footprint down, and we can capture that last bit that the centralized systems can't capture. The other thing we need to focus on is the housing market is booming. Like they're building everywhere, and the infrastructure is not laid out for the centralized water reuse. As I mentioned in a lot of my other presentations, Florida grows by 1,500 people every single day. So there's no pushback on decentralized gray water recycling. So that's kind of where we're at this point in time. But what I'm finding a lot of the time, Tim, is water's the last thing. There's a lot of builders that call themselves net zero or sustainable.
But we don't think about water.
Water's never in the equation. Yep. And they did a study of students in downtown San Francisco and asked people, what do you think you can survive without water or energy? And probably 95% of people said energy. Yeah. Which is scary, especially as a person that's on a mission to save water.
It makes me thirsty for you to say that.
Yeah, exactly. So what they're doing in Florida, and as Tim mentioned, is as we look at this slide here, and I'll just go back one, we're trying to change from a linear water cycle to a circular. We're trying to reuse as much as we can. It's even getting to the point where in 2030, there was a bylaw passed for the state of Florida where they're going to, instead of treating their wastewater and putting it to the oceans, they're actually going to re-inject it into the aquifer. Mm-hmm. Because what's happening is the aquifer is going down so quickly that they have saltwater intrusion that's going to start happening. So this is how we're trying to change our cycle to a circular.
And just to make sure we all are on the same playing field, there's gray water, right? There's potable water, gray water, black water.
Yeah.
And black water is obviously toilets, right?
Yes.
But also kitchen sinks, right? Laundry?
No, dishwashers.
No? Dishwashers. Yeah. Okay, dishwashers. So dishwasher, kitchen sink, and toilets. Everything else fair game for Graywater?
Yes, yeah, fair game for Graywater, yeah. Because we're looking at different levels of organics and different levels of bacteria within those sources of water. So Graywater is looked at as lightly contaminated wastewater.
Yep.
And what we're doing is bringing our shower and bath, air conditioning, condensation, dehumidifier, whatever environment you're in, whether in Canada or somewhere warmer in the United States, we're bringing all that into the device, treating it to be used for non-potable applications.
One benefit of that is that those are all what I call small pipe waste systems,
Yes.
right? So you're not dealing with toilets, you're not dealing with big stacks or anything that's kind of expensive, right? You're dealing with, 1.5, 2 inch diameter, it's kind of small diameter, waste pipes in a system. So
Exactly.
it doesn't seem like re-architecting the drainage in your home would be a significant increase than in cost.
Yeah, no. And the device can be placed anywhere. It doesn't have to be in one specific location. It doesn't have to be in the garage. It doesn't have to be in the basement. I mean, I say basement when I'm speaking to Florida builders and we don't have those here. So, we're really flexible on where the device can be installed.
I got another crazy question, because I ask all these, that's my job to ask stupid crazy questions, but septic systems.
Yes.
A lot of times you get too much effluent in septic systems. So is this a benefit to septic
Absolutely.
systems? Maybe if I reduce, because I should be able to reduce about 25% of my volume of liquid into my septic system, but I have a higher concentration of solids because, right, it's black water only. What's your view on that whole thing?
And we have that question a lot. It's actually, depending on where you are, but we're speaking to wastewater treatment operators or that are looking at the wastewater. It's actually better.
Yeah.
For it to be moving with less of the
Yeah, because I've heard you can get too much regular water in the septic, and that's actually a problem.
Exactly. And to your point is when we're thinking about graywater recycling, we're not using as much potable water. Well, in Canada, depending on where you are, we have lots of water. Our problem is our wastewater treatment plants are not able to handle the new developments. So they're more interested in how can I cut down on my volume.
Which for cities is capital investment. Right?
Absolutely.
Hence, there may be subsidies in some cases. It's not driven by potable water, but it's driven by a lack of interest in the cities in expanding, their waste treatment side of their business, because that's big dollars for a city.
Absolutely. So those are the things that we consider water going in and water coming out. And as you mentioned before, savings of between 25 to 45%. I have people say to me all the time, "How much can a Hydraloop save?" I turn around and I say, how long is a piece of string? Because how many people live in the home? Do you have a baby in the home that you're bathing every night? Do you have a teenage daughter that's showering for 45 minutes?
In which case, it's 100% of the water you use.
Right, exactly. And these are all the things. Every case is unique, and every case we're going to be able to determine how much water can be saved at the end of the day.
So it's more than 25%, really. It can be significantly more, which makes a really big difference.
Exactly. And we do have some people that, they are using rainwater as their backup water. So if we don't have any water that's been recycled, they then plug into the rainwater supply, they filter it, and then they use that to flush their toilets. So there's many different configurations.
So I was touring some Austin homes, and Austin has some kind of environmentally sensitive builders, and water is a big issue in Austin and all that kind of stuff. And there was a builder that was using all rainwater collection for toilet flushing, irrigation and all that side. And it was really interesting. It was a very simple replumbing of the house that allowed them to kind of collect the rainwater, and they use rainwater for all that. And it had an ability that if the rainwater tanks got too low, it would then allow potable water, so it was not like you couldn't flush your toilets anymore. It would fill up with potable water. So it was completely seamless for the homeowner.
And that's key.
It would be really neat to see your system in conjunction with rainwater collection. It's kind of a combination.
Oh yeah, and we do work. Our devices do work together. I mean, we have several individuals that live in California on the Stanford property that are very technological when it comes to all different things in the home. And they are actually cutting down on their water consumption by 65% because they're bringing in their rainwater.
Right. Do you have any schematics that we could share maybe with the audience, that send out later on to show them, here's what a schematic of a system looks like if you're just doing gray water. Here's one if you add rainwater to it, and how it all gets plumbed, what it kind of looks like. Because that might be something interesting for.
Yeah, absolutely. I have one as far as just the Graywater part of it, but then and it's very simple as far as bringing in your rainwater, because we always have a connection to the device of potable water supply. But if you were to branch off and have rainwater as well, we would just show the rainwater, and then you always have to have some stepped filtration, because there's other particles that are going to be in the rainwater that you harvest to bring into the device. So it's really very simple.
I think that would be probably a good piece of collateral to be able to show people.
Yeah, absolutely. And I've explained this before, but what I'm trying to get across with this slide is how we operate. But as far as an educator, I just want to let you know that we're all graywater recycling manufacturers are after the same goal. We need to filter that water. We need to take out any bacteria. We need to take out the organics and the oils and soaps, and we need to disinfect it. We all kind of have a different spin on how we do it. What Hydraloop is focusing on is we don't want any consumables. We don't want the homeowner to have to be throwing anything out, chemicals added to the system. The only thing that needs to be done on the device is once every 2 years, change out.
So I'm kind of a home product tech geek. Can you explain the technology?
Yeah, absolutely.
How does this work? Is it thermal? Is it UV? Is it a combination of thermal and UV?
No.
Or
so basically, it's a series of tanks. The first step is where you can see that middle tank where that blue arrow is. We're bringing in your gray water. We never want raw gray water to be stored, ever, because that water obviously has a life of its own. It's going to become something completely different. So the gray water goes directly into the device. As it's entering from the top, it's becoming very turbulent as it's falling in. So if there's soap in the water, it's all going to foam up and it starts to rise to the top as the level increases within that tank. You can see on the one side, there's a small tube going down. Inside of that first tank, there's a skimmer. So that foam will go over to drain, because it's connected to drain. And what it'll capture is hair, or if men shave in the shower, and all that will go over to drain. Once we reach the top level, the valve is closed, and any other gray water that's coming towards the device, there's an overflow, it'll go to drain. So what happens is the first step, the water is sit and it's let to be very still. We want anything heavier to fall out of solution. We can capture it in that little cone shaped at the bottom of that tank, and then that will go to drain as well. Then what we're doing is injecting air bubbles, millions of air bubbles, because what that's going to do is adhere to any oils and organics. Again, it's going to produce foam, go to the top, and go over the side. If we collect a sample of that water from that tank at this point in time, it's going to have a milky consistency to it. So we've still got some oils in there and soaps. We pass it to the second set of tanks where we've created an MBBR, which is a bioreactor. We have hundreds of plastic balls in there. When we install one of these systems, we let the raw gray water, run for 2 weeks.
So you let the water play in a ball pit for a while?
We let it play in the ball pit.
Right, so
we let the bacteria.
I told you, I'm very technical. I'm getting this.
We let the bacteria.
So the water, first of all, is a foam bubble bath.
Yes.
And then it gets to go play in the ball pit.
The ball pit, yeah.
We got this. This is
and on the balls is bacteria, and everybody immediately goes, "Oh, you want bacteria in the system?"
Good bacteria, though.
Absolutely, because we want any additional organics. Yeah, it's Canadian bacteria. Very friendly. To break that down even further, before the water then goes to the UV disinfection system, and then it's stored in the collection tank. And the great thing is when it's stored in the collection tank, every 2 hours, if no one's used that water, it passes by the UV system again.
Okay, so at that point, it is sterile because of UV and all this treatment. It's not potable. In its clarity, it's clear?
Yes. And the big thing is there's no smell.
No smell. So it's clear, no smell, it's sterile. It's just doesn't pass U.S. or Canadian potable drinking water standards, et cetera, et cetera.
Yes.
But if you poured it in a glass, you probably wouldn't really notice the difference.
You would not notice the difference. And that is crucial, because a white toilet, you bring water into it, it has to be clear water. So that's really important. And those are the things that under the certification that we had to get that they're looking for to ensure that it is it's not going to affect the homeowner. So this is a configuration of the home, and the plumbing that needs to be set up, for example, is we always have to get the water to the top of the device. So if you have showers on the same floor as a Hydraloop, we're going to have to lift that water. But we always make sure we talk with our customer, the home design, show us the design. We'll show you the perfect spot to put the Hydraloop. As far as, how many floors, how far we have to pump the water, all these things need to be taken into consideration. We also offer the customer, you can use this recycled water, you can use it back into your washing machine. You can use it for toilets, obviously, and then you can also put it outdoors for irrigation into a cistern or a rain.
The fact that you can use it back into your washing machine kind of speaks to the quality of the water. You know,
And
when you say you can use it for irrigation, you're kind of going, I'd pour a lot of stuff out on my yard and I don't care. And even flushing a toilet, you're going, as long as it's not discolored or smells, But the idea that you're washing your clothes with it says that this is pretty well treated water.
Yeah, and we're trying to close a loop too on laundry as well, because we can take that gray water into the device and we can put it back. So what happens is when you connect the Hydraloop to the washing machine, it's feeling the pressure of the water and it starts to count the cycles. So we do not take the first 2 cycles of the washing machine. There's too much soap, but there's too much dirt. We will take the rinse cycle that we can pull into the Hydraloop.
So how does that work? How do you decide what water you take and what water you don't take?
When we look at when there's an installation, we work with the plumber and we ask what kind of washing machine they have, and we know how many cycles they have. And then what we're doing is the Hydraloop actually counts them, so we know which cycle is going to be the one that based on water pressure.
And there's a valve that then so
we're connected directly. Yes. And then when we go back into the washing machine, we always stop before the rinse cycle and we use clean water for the rinse cycle. A lot of people are uncomfortable with the possibility that reusable water is going through there. So the final rinse cycle is always.
Well, if they're uncomfortable with washing their clothes with yours, then they're going to be really uncomfortable drinking treated sewage water, aren't they?
Absolutely.
Which is what we do in some cities. So
it's all perception. It's all perception. What this is documenting here is I keep talking about the home, but we can also implement these systems in hotels, in sports facilities, in multi-residential applications. So, but what's better about the multi-res application is we can implement a system in a mechanical room, in a basement, so we don't have to have a single device in every single unit.
Right.
And then we can treat that water and send it back to.
And that's an interesting. This is a standard SKU. You have one basic standard SKU. Is that correct? There's one basic system that you.
2 actually. One
2.
for homes, and then the bigger one we use for larger applications.
So the home unit. How large? How much volume can it take? Like how many bathrooms at home, could I reasonably have, for example, and still just use one of your units? Could I, have 4 showers and could it be a 4-bath, 6-bath house?
Yeah, good question. What happens with the device is it takes 4 hours to treat its first volume of water. If it's filled to the top, it will produce 30 gallons every 4 hours. That's what we can. So we've actually installed these in a home with 6 bathrooms and have been able to produce enough water for all the toilets. And on the multi-res side, what we've done in other buildings is we only treat 30%, out of 100 units, we only treat 30 of the units gray water to provide water to flush the toilets in the entire building.
Wow.
So we always kind of do a calculation.
They got to look at landscaping as well, though, because a lot of apartment complexes spend a lot of money on landscape irrigation, right?
And that's always the first question. What water do we want to use, and what do we want to use it for?
What do we want to use it for?
Yeah.
Interesting. I guess in a residential situation, if you over-capacitized it, it would just go to drain.
Exactly.
So maybe one weekend it's crazy, everybody's taking a shower, you're going through tons and tons and tons of water, and you miss some. But 90% of the time, it's just fine, and it's taking care of everything.
And that's another reason why a lot of people ask, can I connect my bathroom sinks to this? Absolutely you can, because when the water that's gone through the system, when it's tested, they put toothpaste in it and shaving cream. But here's the thing, if somebody just washes their hands, and then that water goes down the drain, and then nobody has a shower, the Hydraloop receives a really small volume of water, and they're gonna treat it. It takes 4 hours. We don't want that volume. We want the massive volume. We want the load of laundry. We want the shower volume. And then that was the most efficient way to treat the water.
Interesting.
One thing really unique about the Hydraloop device is data. These systems are great. We can save water, but if we don't know what it's doing, it doesn't mean anything to us. My goal is more as of an educator than to sell devices. I want to go to all municipalities, regulators, and say, this is what we can do. So we have many pilots throughout North America that we're working on where they install these devices, collect the data at the end of a year. They'll say, this is how much water we save. So if you check out the drawing with the bar graph, you can see that over a year, you're going to be able to see per day, per month, how much this home is saving. And by that, the municipality can look at it and go, yeah, we need to be offering these builders rebates to implement these.
Fascinating is to do a study and look at what the cost of added wastewater treatment plant is per home. You know, because you look at the bond packages, right? You know, and it's like, you know, $192 million, you know, expansion for wastewater, blah, blah, blah.
Exactly.
And the question is, well, how many homes is that? Is that 100,000 homes, 1 million homes? I mean, how many is it? And look at the cost of your unit per home. And it would be really interesting to see, you know, economically, which is even more effective for a community, which you could get to the point where a community would be willing to pay for this first before it actually goes after the huge industrial expansion of wastewater treatment.
Yep, absolutely. No, that would be a great study to have. The great thing too about what we have, the device manager, is 90% of any troubleshooting, service, maintenance that needs to be done on the system can be done remotely. So if you have an installer that's installed 10 devices in a development, he has all that data in front of him, and he can guide and monitor and look at all the devices as they run through over time. We also have an app with the homeowner, and I know a lot of people are, oh God, another app. But with this, we want to get the homeowner involved. How did we all start recycling? As a kid, I went home and said, Mom, why are you putting that glass container in the garbage can?
You shamed
and we
mother.
harassed them and shamed them. This is the same. We're trying to implement these in schools as well, and putting up huge monitors, and the kids can get excited about how much water they saved every day. So this is an education piece, and it helps the homeowner be more cognizant of the water that they're actually using. Certification is really important. Everything that we have has to be third-party certified, whether it be electrically or performance-wise. So this is something that, you know, to look for any manufacturer that you're using. And this is just to go through exactly how it's engineered and how the device is pieced together. It's simple. It's to the point. There's nothing complicated about it. We want to make sure that the homeowner has it in there. They forget about it. They just know that they're saving water with this beautiful piece that's in their mechanical room.
Well, we talked now about how we treat water. We're gonna switch. We're gonna talk about the problems of getting water to the house. Now, the neat part, Jonathan's going to tell you, is some of our plumbing systems automatically recycle water randomly through pinholes into your structure. Yeah.
Exactly.
It's incredible.
I believe it.
You have some homes come with their own internal in-wall irrigation system, and it's just incredible. We didn't even know it was a feature. It's a gift, free of charge to all of our clients. So Jonathan's going to actually show us all that. Wait till you see it. It's very exciting unless you were the builder.
We should work together. Yeah, so just wrapping up, and you guys have all seen this, different devices for different applications. One thing I really want to emphasize is it's not one size fits all. We need to know how many bathrooms, how many people, what do you want to use the water for? All of this is really important for us to be able to recommend the right equipment for the right application. This is just showing how they're installed in the home. We have a convenient LED light on the front, so the homeowner can go, oh, it's purpley blue. It's working right now, or it's white. All right, everything's just sitting, or it's red. My plumber or installer is now online looking at how to solve the problem. A typical home can save between 10 to 15,000 gallons in a year. So let's look at 10 to 15,000 gallons of potable water savings. Let's multiply that times 100 homes in a development, and you'll start to see the impact of what gray water recycling can do. There was actually a study done, and it said that if we put a gray water recycling system into 50% of the population worldwide, we can save 70 billion gallons of potable water every single day. And that sticks with me, and that gives me goosebumps, and that's why
you work where you work.
Exactly. So, and this is just to show different configurations. This is a cascade that we have in a multi-residential type applications. So, for example, in a 300 student housing, saved almost 350,000 gallons of water use in a year.
Very cool.
And I always like to emphasize this. We're in Florida. I want to celebrate Florida, offering the best incentives. Florida is being proactive instead of reactive when it comes to their water supply. So they will, if Mr. Joe home builder installs a device into one home, let's say one of our devices costs $5,000, he will get a $2,500 tax rebate from the government. Let's say he wants to build 200 homes and he's going to put a device in every single one. He can build 35% more homes, provided they fit on that plot of land, because he's implementing graywater recycling.
So there's some pretty big incentive, not just rebating, but also the ability to densify.
Absolutely. They're leading the way. And I'm going to take this example. They're setting a precedent, and I'm going to pull this through the rest of the United States and see what we can do. And
Cool.
on that note, I'm sorry everyone had to listen to that presentation twice. I hope you took something else different away from that. Thanks to Tim. I really appreciate the questions. And
Now our gift to our customers, the in-wall sprinkler system.
Yeah. Thanks, my friend.
Thank you. So we've spoken with several of you over the last day and a half. I'm going to try to mix in a couple pieces of information here that we haven't necessarily touched on in as much detail. It's all about clean, safe drinking water. So it's essential to our bodies, it's essential to our lives, it's essential to our communities. The question is, how do we keep our water clean and safe to drink? So as Americans, a lot of us, we just take it for granted. We go to the faucet, we open the tap, water comes out, and we know that we can put it in a cup and drink it. Anybody who's traveled internationally knows that that's not always the case everywhere you go. But even here domestically, there are several emerging challenges to water quality that are impacting both our homes and our infrastructure. We were just talking about water scarcity and the impact that that has. That's leading to dynamic water sourcing. If you live in an area where you have, say, there may be a lake and a river, maybe there's also an aquifer, multiple places that your utility can draw off of, the utility is now having to switch dynamically between where they're getting their water based off of what the water levels are, if there's a contamination issue, if there's a flood event that contaminates surface water, so they have to go underground. There's a lot of dynamic water sourcing, which leads to changes in water treatment. There's also evolving water contaminants. We've had such a great infrastructure for such a long time on how to treat and kill bacteria and other nasty stuff that can get into our water. But bacteria are alive too, and they are learning and evolving to resist the traditional methods of disinfection. So we have to come up with new and different ways of treating our water. And growing utility service areas. We're building farther and farther and farther away from our core cities. And as the utility service area gets bigger, the utility has to figure out how to keep that water safe, not just at the home 15 miles from the plant, but now at the home that's 50 or 75 or even 100 miles from the plant, depending on how large that water utility service area can be. So how are our communities reacting to keep that water safe? Well, this is a very simple rudimentary diagram of water treatment. So there's pre-treatment that happens right before, as they take the water out of the lake, out of the river. They'll give it some pre-treatment. They'll do large particle filtrations. They'll take the leaves and the sticks and all the other stuff out of there with a mesh. And then you go to primary disinfection. Primary disinfection is intended to kill the majority of the bacteria and viruses and algae and other stuff that's in the water. Then they do fine particle filtration. They clarify the water, take out all the little tiny things that you can't see with the eye. And then you go to secondary disinfection. Secondary disinfection is the treatment that's providing the residual disinfectant. So secondary disinfection is all about keeping that water safe from the moment it leaves the treatment plant all the way through until it reaches the point of use inside your home. So there's three methods, three types of chemical treatment that we use today for primary or secondary disinfection. Chlorine's been around for the longest time. I think the first chlorine water treatment was done in either the early 1900s or the late 1800s. It's a well-established, long-standing technology. It can be used for both primary or secondary disinfection. And it's effective against a wide array of pathogens, but it's not effective against everything. The really concerning thing with chlorine is in the 90s, early 2000s, the EPA discovered that when chlorine interacts with certain types of contaminants, the byproduct of that interaction, while it kills the bacteria, it creates a new compound that can actually be more harmful to human health than the bacteria that it was killing. These are called disinfection byproducts. And with chlorine, its effectiveness diminishes over time. It's not as long lasting. So as we're building farther and farther out, the effectiveness of chlorine at mile marker 75 is not as strong as it is at mile marker 10. So water utilities started looking at chloramine instead. Chloramine is typically used as a secondary disinfectant only. And that's because it lasts a lot longer than chlorine, but it also takes a lot longer to kill pathogens. So it's slower acting, but longer lasting. It has fewer harmful byproducts, and it has a lower impact on the taste and odor of the drinking water, but it's highly corrosive to copper piping. I was talking with somebody earlier this morning, I think they're out of Colorado, who was explaining they have copper pipes in buildings that they've had for 10, 15 years. And all of a sudden, they're having all of these copper pinhole leaks. And that's the result of chloramine stripping that internal patina, that protective internal layer of corrosion, re-exposing the raw copper, and allowing that copper to continue to corrode and degrade, resulting in pinhole leaks and corrosion. The newest method, and this is a rapidly growing technology, is chlorine dioxide. It can be used as either a primary or a secondary disinfectant. And it is both fast-acting and it's effective against a broad range of pathogens. So not just bacteria, but viruses, algae, all of the bacteria that we've discovered in recent years that chlorine can't get rid of, chlorine dioxide has been shown to be effective against. There's minimal byproducts, little to no impact on taste and odor. In fact, I'll talk in a little bit about an example from Hamilton, Ohio, where they've actually won awards for having the best tasting drinking water in the country based on the fact that they're using chlorine dioxide water disinfectants. It can be a little expensive to implement. It's a higher upfront cost, but a lower long-term operating cost for the utilities. So it's more of a capital investment than switching between chlorine and chloramine. And it has a very high, what they call an oxidative reduction potential. Oxidative reduction potential is a fancy science word for how strong is the disinfecting power of the water. The higher that number, the easier it is to kill bacteria. However, higher ORP can also be damaging to certain piping products. How many folks remember polybutylene? So a few folks.
How many remember it fondly? No?
I know several repipe contractors who have very fond
Oh, they think it's very fond, yes.
They've sent their kids and some of their grandkids to college on the back of the polybutylene class action settlement. Polybutylene is for those who don't know, was a flexible plastic product that was introduced into the US in the 1970s. And it was actually the subject of the largest construction product defect class action settlement in American history. It was bigger than lumber liquidators. It was bigger than Chinese drywall. And it was because they had to repipe over 300,000 homes. So when polybutylene gets attacked by chlorine, the chlorine molecule swoops in, gets to that carbon chain of the polybutylene molecule, and it breaks the chain. It creates a micro crack that over time opens up deeper and deeper under temperature and pressure. More chlorine gets into that crack, creates more chain scission is the science word. It breaks that carbon chain deeper and deeper. Eventually you get a pinhole leak. PEX is a chemical cousin of polybutylene. They're both part of the family polyolefin, which means essentially they're just made up of carbons and hydrogens. There's nothing else there on that carbon backbone. When chlorine comes in and reaches the carbon chain in PEX, it has the same effect. It breaks that carbon chain, creating the microcrack, which then grows and develops into a pinhole leak. So polybutylene, we've got a field failure photo, and then a failure analysis under magnification of what that crack looks like. PEX, you can see field and laboratory failures as well. They materialize in almost exactly the same way. It's the same failure mode between polybutylene from the 70s and 80s and PEX today. So the Plastics Pipe Institute, which is a trade organization that's made up of manufacturers of all sorts of plastics, PEX, CPVC, polypropylene. It's a broad-reaching industry organization. They've issued 2 technical notes on this topic. The first technical note was issued in about 2018, and it was Technical Note 53, which defines some of the operational limits of the chlorine ratings applied to PEX. So they identified 3 key elements. Temperatures above 140 degrees Fahrenheit. Those of you who remember high school chemistry, the hotter a system is, the more aggressive the chemical reaction is going to be. So anytime you get that temperature up above 140, and that's not just water temperature, and that's an important distinction. Chemical reactions depend on the thermal reaction.
Right. So if you're running pipes in an attic in Texas, you could easily hit that, even if it's cold water line.
Absolutely. So if you're in an attic in Texas and that pipe's sitting there unprotected, if it's a 100-degree day, it can be 160 degrees in that attic. The ambient air temperature bakes that pipe and creates the temperature environment for an accelerated chemical reaction. Pressures over 80 psi. This is also, again, by code, you're supposed to try to keep your pressures under 80 psi. I have seen areas where street pressure is as high as 160. I have seen areas where the street pressure is as low as 40. So it's very dependent based on where you are, what the water use dynamic is in that area.
No, the other interesting thing is transients, water hammer type transients in a system. I'm just wondering if that, even though your base pressures may be lower, if you have these kind of transitory spikes, would that allow the failure mechanism to begin?
Absolutely. We've seen situations where intermittent water pressures above 80 psi have caused accelerated failures. Not necessarily in the case of something so intermittent like water hammer, where it's present for just a second, but there have been communities where during the daytime, when people are drawing off of the system, the water pressure is 60 to 70 psi. But overnight, when nobody's drawing off of the system, pressures slowly rise to 100, 120 psi. And that cycle of being elevated for 4 to 6 hours every night does cause the accelerated rate of failure. And then that last point is that ORP, getting back to that measure of how strong is the disinfecting power of the water. Anything over 825 millivolts is outside of the limit of the chlorine rating. So while they do test the products, that test for chlorine resistance is not absolute, and it has to function within those limits. But more recently, in 2023, PPI issued Technical Note 67, which cautions against the use of chlorine dioxide in a wide range of materials. In fact, in that technical note, they say that chlorine dioxide has been found or is believed to be detrimental to almost every piping material in use, with the exception of CPVC. CPVC is the only material that is immune to chlorine dioxide or other chlorine-based disinfections because it's an inherently chlorinated compound.
Now, I'm afraid the next technical bulletin is going to see abandoned ship, put on your life vest or something like that. I mean, it's like, how bad is it going to get here? Okay.
Bring us back up.
So really building off of that technical note, based on the issuance of that, we've actually seen multiple manufacturers of PEX products now update their installation manuals, where they now explicitly state in their installation guides, we do not recommend using our products as part of any potable water distribution system in buildings where chlorine dioxide is used for secondary disinfection. Now remember from the chart before, secondary disinfection means that whatever that disinfectant chemical is being used for residual disinfection. So if there's any chlorine dioxide in that water when it reaches the home, they do not want their products to be used because of the risk of chlorine degradation caused by that high oxidative reduction potential. And so you can see there's 2 manufacturers there that use a very, very similar statement. And then the third actually refers directly to the PPI technical note in their installation guide. By making this part of their installation instructions, they are now making it the responsibility of the contractor or the specifier to ensure that they don't have chlorine dioxide in that home with where their pipes are being used.
And let me ask you a super quick question to the audience, because I've asked this multiple times. I always ask this when we get together. How many of you test the water before you build in a community at that community source? I've never had a builder raise their hand. So we're going into this process completely unaware of what the water chemistry and content is, and yet we're specifying plumbing products, which may or may not even be within the basic installation instructions and the warranty of the product. That's the frightening issue. It may mean everything's perfect. Or it may mean that you've built a home that 6 to 8 years later, you're going to have 150 homes and you're going to be part of a class action, and you don't have anything to hold yourself against, because right in the assembly manual, right, the installation manual said, don't use it in the condition that you're installing it in. And you chose not to test the water. That's going to be a highly litigious and very difficult case to defend.
What's even more challenging for a builder and for your trade partners is water changes. I mentioned at the very beginning how as we change dynamic water sourcing, sometimes they have to change how they treat their water. Well, you could do all of the due diligence today. You could test the water, you could talk to the water utility, you could get the water quality report, you could find out who the right person is at the water treatment facility that makes those decisions, track him down in his front yard and ask him, are you going to use chlorine dioxide? And he could say, no, we're fine. And then 4 or 5 years later, something changes. They can implement chlorine dioxide in that water utility. And now a previously installed system where all the due diligence was done is now no longer compatible with the local water conditions. But it's not just in the installation instructions. And it's not just about chlorine dioxide. On the left-hand side of this table, you'll see screenshots of the warranty language used by every manufacturer of PEX products sold in the United States. And this isn't the front page where they tell you all the good, happy stuff of this is how many years it is and this is how much we'll pay you if something goes wrong. This is on the back side of the warranty where they talk about the exclusions. And every manufacturer of PEX pipes contains an exclusion in their warranty that says if the system fails due to aggressive or corrosive water conditions, the warranty is void and will not cover that failure. Because they know that there is a water chemistry concern. And what do you exclude in your warranties? The things that you know might cause your product to fail. So they have the limits on temperature, pressure, and ORP that we talked about from TN 53. A lot of manufacturers also in their installation guides now prohibit the use of chlorine above 4 parts per million within their pipes. But again, that dosage is set by the water utility based on EPA recommendations, what they need to do to keep the water safe. It's outside of your control, outside of your contractor's control. And they have these explicit warranty exclusions. So all these manufacturer warranties in the fine print really are about protecting them, but they leave plumbers in the dark. I guarantee you, if you go back to your plumbers today, tomorrow, when you get back home, and you ask them, what's going on with this chlorine situation? They won't know anything about it because these warranties, these installation guides, it's hidden in the fine print. The chlorine dioxide recommendations that I showed you on the last slide, one of them's on page 93 out of 140. The other one's on page 77 out of 95. They weren't there 3 or 4 years ago. They're there now. Nobody's going out and talking to the plumbers and educating them and saying, hey, we just updated our installation guide. Please don't use us here. The sales guys aren't out there selling against themselves. So it's not the plumber's fault that they don't know. So chlorine dioxide, I mentioned before, it's really increasing in usage in the US. And one of the key drivers of this is around 2019 or 2020, the EPA and the CDC raised an increased concern about 2 contaminants. One's called cryptosporidium, and one is called Mycobacterium avium. And I can't remember which one's which because I'm not a biologist by trade, but one of these causes really severe stomach illness, and the other one, when aerosolized through a shower head and inhaled, can cause a very severe respiratory illness. So these two contaminants cannot be deactivated by chlorine or chloramine, but chlorine dioxide is effective against them. So as water utilities are testing their source water, if they identify or have concerns that they may see these particular contaminants, which can only be killed by chlorine dioxide, which are now on the radar of the CDC and EPA, it's really forcing them to look at chlorine dioxide more aggressively. There's also some utilities that are just more concerned about drinking water taste and odor. Here in Florida, if you're July or August, your drinking water is going to taste like it's coming from a swimming pool. It's going to have that swimming pool smell to it because there's just so much nasty stuff in the water. The high temperature causes it to grow. We've got to treat it really aggressively. Chlorine dioxide can kill all that stuff, all the bacteria, with the same disinfecting power as a much higher level of chlorine, so you have almost no impact on taste.
The problem is for the piping, you've showed either one's bad.
Absolutely.
Right? If I go over the 4 ppm, right, for chlorine, that's bad. If I go to chlorine dioxide, that's bad.
Absolutely.
Yeah, so it doesn't really matter.
It really doesn't matter one way or the other. But it's driving folks to this chlorine dioxide usage. And so right now, we're 2/3 of the way through the data collection from the EPA's, so they call it the UCMR data set. They'll be done in early 2026, but already with 2/3 of the data collected, chlorine dioxide usage is up 94% versus 2020, and it's 15 times higher than it was in 2010. If the last third of the data comes in at the same pace as the first 2/3, ultimately we're expecting to see about 150% increase in the usage of chlorine dioxide over the last 5-year period. So where is this? The answer is it's just about everywhere.
We don't build there. Yeah. Okay. Awesome. We all dodged a bullet. Son of a gun, that's awesome.
Now, each of these pins represents a regulated water utility. Some of them are very large and service 100,000 people or more. Some of them are very small and might only service 1,000 or 2,000 people. So that's not to say that chlorine dioxide is absolutely everywhere, but it can be anywhere. And we actually are working on an interactive map that we'll be putting up on our website shortly that will allow people to take a look based off of the current available data to identify where is chlorine dioxide currently, and is it a concern for you? So how do we solve the problem? Well, if you remember how chlorine attacks polybutylene and how chlorine attacks PEX, this is Flowguard Gold CPVC. And you'll notice there's something very different about it right off the bat. You don't have to be a chemist to see this. There's a lot of green balls on our carbon chain. And that means that we are a chlorinated compound. There's chlorine already there. Depending on where that chlorine tries to attack, it just can't reach the carbon chain. The chlorine repels the other chlorine. It keeps it away from the carbon chain. And that's what makes us chemically immune to any sort of degradation, whether it's chlorine, chloramine, or chlorine dioxide. There's nothing that can be put into that drinking water that is safe for human consumption that's going to cause any damage to our product. And you can actually see here, these are photos. On the left-hand side is brand new Flowguard Gold. And on the right-hand side, it's pipe that was taken out of service after about 25 years in Maryland. And aside from a slight shift in color that comes with aging, the product looks exactly the same. No damage. So Flowguard Gold is immune to degradation from drinking water caused by chlorine, chloramine, or chlorine dioxide. We've been around in one way, shape, or form since 1959 with over 13 billion feet of pipe installed across American homes and businesses. And we have the proven technology to solve the problems with emerging water treatment methods. Of all the known technologies, there's nothing that can be implemented that would cause our pipe to fail. And that's Flowguard Gold Plumbing Systems.
And all of you can pick up your diplomas. They'll be signed over here. Please give your full name, middle initial. You'll get credit for this. Is that incredible? First of all, are both of these people incredible? Did they share? Did we learn something? We learned something. All right, how about a question for either one of them, both of them? But I think it's a really big issue. For me, builders should do multiple things. I've heard different versions of your pitch multiple times, and one of the really interesting things to me was this issue of how far away you are from the treatment plant. Mm-hmm. matters. Because if they keep extending their jurisdictions, they have to change the chemical makeup of the water so that this person on the end still has safe water, which means your community that's close to the treatment plant has a very different chemical composition, right, than the one way at the end of the treatment plant. So to me, step one is, it seems like if I was going to get back into the production home business before I bought a bunch of land, even I could buy the land, but before I spec what I'm going to put into the home, I'd at least want to have some chemical analysis of the water to understand what I'm dealing with and to understand the treatment process and the options and any forward view they might have.
Yes.
Granted, doesn't mean in 10 years they might not change and it could be a mess, but at least as a builder, I did my due diligence, and for the current water conditions, we met the specifications, we were within warranty, we were within blah, 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 at least, right?
Absolutely.
If I want to future-proof the homes and say, look, this home is future-proof, then it seems like you have much less option. You've really got to go with a product that's going to be immune to the family of chlorine issues.
If I can add to that, with regards to, I have a background, because I come from a UV disinfection technology background, so cryptosporidium, I know them very well. And what it used to be was they didn't treat for crypto or giardia unless your water source was influenced by surface water and just strictly groundwater. Well, it's very rare that you can find a source of water now that's not impacted by surface water. So not only will they start to push this more, even if you use UV disinfection, because it's one of the only things that it's effective against cryptosporidium, they still need to worry about down the line. It sounds to me that chlorine dioxide, it's going to increase. So
absolutely. What we see a lot of now with water utilities is they're implementing for primary disinfection, they're using a lot of UV, maybe ozone, which is another method that can be effective. And then it's for the secondary disinfection, it's that residual disinfectant that it really keeps that water safe all the way to that into the fixture. And I've always said, I've never heard any manufacturer of any sort of water treatment technology say that they're 100% effective. It's always 99.9%. So there's always that risk that something sneaks through. And that's why it's so important that we have that residual disinfection, whether it's chlorine, chloramine, or chlorine dioxide. And it's that residual that once it reaches the home that can cause the issues in both copper and PEX products.
But now we need a residual disinfectant that goes further than it did before.
Absolutely.
Because housing is, like you said, it's expanding more and more and more, and it's not slowing down.
Well, these are my two best. Oh, we got a question. Fire away.
Oh, absolutely. Yeah, definitely you'd be able to do that. And I mean, I'm fascinated by this. I'm a water geek, but no, absolutely you can do that. There's no implication as far as installing that with that, for sure.
So there's nothing that I've seen in any of the PEX manufacturers' guidelines that affect with whole home treatment. I've talked with several folks in the water treatment, the home filtration industry, and the general takeaway that I've come from is each type of disinfectant needs a different method of removing it once you get to the filtration. So they'll often look and say, well, you use chlorine or you use free chlorine. And so we're going to use this particular type of filtration system that's effective against free chlorine. If they use chloramine, then it's an entirely different mechanism to remove the chloramine from the water. So they can do, and I don't want to put words in any water treatment manufacturers' mouths, but my understanding is they can create systems that are effective against removing the various things that are going to be used. But when the water utility changes the treatment method,
you have to change
you have to change your water filtration. And the unfortunate thing is nobody notifies you when water treatment changes. The utility is not going to send out a note.
On to that point, when you mentioned, as long as the disinfectant is below 4 ppm, unless you have a chlorine detection system in line of your water, you will never know.
Right.
That. And like you said in Florida, in the summer, the water tastes different because of the heat and everything. So why not be safe that you're covered for everything?
Well, these are my two favorite water geeks, and I hope they're your two favorite water geeks now. I want to thank you, and thank you too. Fabulous job.